Good afternoon, everyone. Am I audible?
Yes, ma'am.
Okay. So, respected teachers, respected guests, my dear friends, I welcome you all to the webinar on advancements in marine technology. Before we proceed, I would like to request you all to keep your mics mute and your cameras turned off at all times during the while the webinar is going on. Okay. So before we begin, let us invoke the blessings of the Almighty with a recitation from the Holy Quran. I would like to request Josefa to please start.
Am I audible?
Yes, Josefa.
Yeah, thank you. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. يؤتي الحكمة من يشاء ومن يؤت الحكمة فقد أوتي خيرا كثيرا وما يذكر إلا أولو الألباب صدق الله العظيم. Translation: He gives wisdom to whom he wills, and whoever has been given wisdom has certainly been given much good, and none will remember except those of understanding. Thank you.
Thank you so much, Josefa, for that wonderful recitation. So today we have with us Dr. R Venkateshan sir and Nanda Kumar sir, who will be taking us through many advancements which are happening in the marine technology field. So we also have with us our guests of honor, the Dean of Zakir Hussain College of Engineering and Technology, Professor Parvez Mustajab. I would like to request sir to please address the audience.
Okay, thank you very much for giving me this opportunity. Am I audible to everybody? Am I
Yes,
audible?
Yes, sir.
Yes, sir.
Okay, thank you very much. Professor Sufyan Beg, the principal of ZSCT, Dr. R Venkateshan and Mr. Nanda Kumar, Professor Salim Anwar Khan, the moving spirit behind this, and members of MTS, AUV, ZSCT student section, attendees of this webinar, Assalamu alaikum to all. I welcome you all to this important webinar series. I'm happy to note that after 5 long years of struggle, MTS AUV ZSCT Club got recognition in the form of becoming the 9th MTS student section in India. This is really a good achievement. Faculty and students involved in this activity needs big applause. It is expected that due to this formation of this society, the engineering graduates from our college will have great exposure to undersea, marine operations and research. I am informed that our students are already taking part in various activities related to this area and have won many prizes. Some of the achievements of the club: our team was shortlisted out of 150 international teams for Singapore Autonomous Underwater Vehicle Challenge, which was cancelled due to COVID-19. This club was placed in top 10 innovation clubs and was awarded at Rashtrapati Bhavan. There had been many performed exceedingly well. I hope that more and more activities will be taken up by the club in future, and expect that our team will bring laurels to the university and college in the future. I wish all the organizers a great success and wish that all the attendees will take maximum advantage of the webinar series on advancements in marine technology. Thank you very much, and I wish you all the success for the seminar.
Thank you so much, sir, for your enlightening words. We also have with us the principal of the Zakir Hussain College of Engineering and Technology, Professor Sufyan Beg. Sir, would you please be so kind to us to address the audience?
Thank you very much for giving me this opportunity. Dean of the Faculty, Professor Parvez Mustajab Sahab, our guests, Chief Guest, Dr. N. Venkateshan and Mr. Nand. It is really a great honor for us to have this webinar on advancements in marine technology and have the eminent speakers like Dr. Venkateshan and Mr. Nanda Kumar speak on this occasion. The Zakir Hussain College of Engineering and Technology, as you might be knowing, has already completed 75 years of its existence as an engineering college, even though the university is 100 years old. And as an educational institution, we started in 1875 itself. So that way we have a very rich legacy and a long history of educational institution and imparting education to the community of India in general and the Muslim community in particular. It is said that we are a secular university with Islamic ethos. So that way we are progressing leaps and bounds, and our alumni have reached to great heights. I would like to inform you that we have produced an Olympic gold medalist from our engineering college in Zafar Iqbal. We have produced many CEOs, we have produced MLAs, we have produced noted film director and producer, and so many people who have graduated from this college. So there's a rich legacy. Right now, we are performing very well in terms of having the NBA accreditation for a full term of 5 years for all our UG programs and many of our MTech programs, which is a rare feat because we got it twice, once in 2009 for 5 years and again in 2016 for another term of 5 years. So that speaks volumes about our performance as far as the national scenario is concerned. And particularly, we give a lot of encouragement to our students' clubs. AUV Club, Autonomous Underwater Vehicle Club, is one of the newer additions, I would say, a younger club, because we have had Robo Club and SAE Club, Society of Automotive Engineers Club, already existing, who are looking after the design of Formula cars, FE cycle, and so forth. Similarly, Robo Club does a lot of activities in all the different branches, varying from computers, electronics, to all the way civil and mechanical problems are being solved. IoT, there is a lot of thrust area. And now this club, which is a new club and a young club, but it still has been performing very well, and it has very fittingly rose to the level of the already existing clubs. And I must congratulate Professor Salim Anwar for spearheading the activities in this club, and all the students, volunteers. They need to be congratulated for doing hard work to make this club see all the success in the different facets of technological advancements. Particularly the recognition of this club by the Marine Technological Society recently, that has added a lot of weight to this club, and I look forward to all the development activities and research activities under the Marine Technological Society that will be coming, and the benefits will be accrued by the students of this club. So I welcome you all, and I congratulate the club members, and I wish all the success in all. Thank you very much.
Thank you so much, sir, for your kind words. Um, so before we move on, I would like to make a small announcement. We are also live on YouTube right now because of the sheer number of registrations we received. We crossed 120 registrations, Alhamdulillah, this time. So due to the limit of the meeting platform, so we have gone live on YouTube for the very first time. So we'll be starting with the program now. So we have with us our first speaker, Dr. R Venkateshan. Dr. R Venkateshan has 37 years of experience in the field of ocean science and technology, and has earned his PhD degree from Indian Institute of Science, and is a US Fulbright scholar with honorific position at the University of Massachusetts at Dartmouth, USA. He passed PG diploma in maritime law at the Tamil Nadu Dr. Ambedkar Law University in 2019. He has to his credit 130 papers in 64 journals, 3 books, 7 products technology transferred, 2 patents awarded, and 5 applied. He holds many positions in technical societies, including the executive member of IEEE Madras section and the senior member at IEEE Coordinate at IEEE Student Project funding NIoT students autonomous underwater vehicle competitions, and has traveled to 38 countries, led delegations at the UN meetings at UN New York, UNESCO, IOC Paris, UNEP Kenya, and many more. He is honored with 24 awards, including the UN Outstanding Service Certificate by WMO and UNESCO. And so I would like to request Sir to please address the audience.
Thank you. I'm trying to share my screen. Just give me a minute. Is my screen visible now?
No, sir.
Okay.
Yes, sir, it's visible now.
I've disconnected. I'll do it again now. We
No,
tried
sir.
for this meeting. Let me try again. Sorry, we had tried earlier. It worked. Now some issues, technical issue. Is it visible now? Is my screen visible now?
Sir,
Yes, sir.
it's showing loading. Yes, sir, now it's visible.
Yeah, only thing I can't show you the full screen. You have to manage with this way of presentation. If I show full screen, then it won't be moving because I'm using the window of this. Yeah. Is it visible now? Shubham, is it
Yes,
visible?
sir.
Yes, sir, it is visible.
Is it changing? I'm changing the slide.
No, sir, it's not changing.
No, sir.
We manage. Thank you very much. Good afternoon to all. Respected Professor Parvez and Dean of the college, and Professor Saifbeg and Principal, and Professor Salman Anwar, and the students of MTS AUV ZHCAT student section and AUV club. It gives me immense pleasure to be associated with the Sagir Hussain College of Engineering and Technology. I still remember when we started this AUV competition way back in 2011. They were the first few student teams who participated, and I'm glad that they have grown in, and they have also supported this AUV competition, which NIOT has been spearheading in for more than 9 years. So even though you are located in hinterland, the interest what you have shown to work in the marine technology and the way you have associated, and this today's program really shows the students' involvement. And myself and the secretary, Mr. Nandakumar, we are glad to be associated. To start, before my starting my lecture today, I thought for other listeners, you all should know about MTS. This India section was started in way back in January 2016, and we have 9 student section, as the dean had mentioned about it, and you are the 9th one. And during the recent meeting, the secretary has promoted to have a signature program for each of the 9 student section. They have come forward to have each one of them. I'm glad that today, in the end of this program, program. The student counselor, Professor Anwar, will be announcing about the ROV competition, which will be the signature program of the student section. We have close to about 120 events we have conducted, and we have received the best section award, and one of our student section last year received the best student section award, and I could have the two more awards of Lockheed Martin and the fellow award. That clearly shows our involvement to this discipline, and also to bring the students to get motivated in this regard. We have been conducting many other student programs, particularly student story writing competition and many more things. There will be one more program which will be launched by IIT Delhi that will talk about 3-minute project presentation. That is to improve your skill so that you get employed everywhere. I will start today. Again, I thank for the opportunity given. I will briefly touch upon in the next 20 minutes about this new topic, which you all must be coming across in your life. Now, how that can be applied on our day-to-day challenges, what we face, and how that will be useful for many of our society. The nature knows best with the millions of years to perfect this technology, and nature is an excellent source for innovation. So innovation can be, even though we struggle a lot, but nature has evolved it over the period, and there comes the field discipline of biomimetics, which is really doing wonders now, and all of us are looking for solution from the nature. Coming back to underwater technology, I am associated with UNESCO IOC Intergovernmental Oceanographic Commission, and they have launched a UN Decade of Ocean from this year. I am sure that you all can get involved into that, wherein there is a need to understand about the ocean. Unless you know what we have with us, 70% of the earth is covered by ocean, by using different tools. The earlier we were using ship as a mode of measuring the underwater parameters, both physical, chemical, biological. Now, autonomous tools are required to understand about it. Here comes the role, and the ocean is such a condition, the marine environment is so complex and so dynamic, and the currents and waves and many other things are going to have a major role to play. But having this all, these different robotics have been developed, and they are all working. Particularly the glider, they are used, which uses less energy, and using the difference in the salinity or the variation in the weight, it can dive down. Similarly, there are ergo floats which are collecting valuable data. Our understanding on El Nino, La Nina by measurements of temperature and salinity have improved a lot by these autonomous tools which are deployed at sea. Now, when we use such tools, we have our own challenges. There is a limitation of the energy or power consumption by the tools which are deployed at sea. So, this complexity can be resolved by understanding about the nature. Where the 9 basic principle, the Jenny Benz talks about that nature runs on sunlight, nature uses only the energy it needs, nature fits form to function, nature recycles everything. Very important for us. We are polluting the earth, what we are living with, non-recyclable plastic. These plastics are reaching into the ocean. Even I have a project to study marine plastic in the ocean, which is really being havoc to us. Basically, we all know that these are covalent bonds, and even though they disintegrate to tiny pieces, that will remain forever. This is what is an unfortunate footprint what we are leaving. But nature recycles everything. Nature rewards cooperation. Nature banks on diversity. Nature demands local expertise. Nature covers excess from within, and nature taps the power of limits. So the diversity is very important for us. The right picture what I show is, we mechanical engineers, many of us, we know that we are working on 2 fluid dynamics, air and water. For the fluid dynamics remains almost same. Many of the oceanographers whom I come across, they are basically mechanical engineer turned into that. This picture clearly talks about how the nature has evolved 2 different systems using the same principle to overcome their requirement of moving in the air or underwater. Now, when you talk about ocean, there is a need to have a sustainable development. That's what SDG 14 talks about, that life below water. So one of the things which comes to our mind is that biomimicry, the nature. Can we think about it, particularly medical advances? When you talk about antibiotics, the super bugs is one thing which has come from the underwater animal. There are also study about particularly underwater volcano, where the chemiosynthetic process taking place, and also in Arctic and other region extremophiles. So these biotechnology component of it, and mechanical navigation and propulsion, particularly the European seas and sea turtles. Many of you are aware, in Orissa, the sea turtles comes in the month of March, April, and they know where do they come. How do they know? How do they come back to the respective place? This second picture clearly talks about they're having they know about magnetic earth and they follow the same path. There are also tagging studies, satellite tags have been attached to that to know how they return back to the same place for the breeding. So this is what we have to learn from the nature. And resilient materials, there is another thing, materials development, particularly the sponges, marine sponge, they have a larger role to play to understand about that. So materials and mechanisms, the advancement of the materials can learn from many other things. So you have diversified colors. You can see about these animals having these photonic crystals and how these ceramics can be evolved from the low temperature, how these animals are there. I will show you one picture about how the underwater sponge is, glass sponge is there in the end. And bioadhesion, I will also talk about it, bioadhesion. We know very well that Velcro, it has come from the understanding from these biomimicry and geochal, where it can get attached to the surface by having a glue. And the Lotus Effect, I will also describe now in this talk how this Lotus Effect is used for anti-fouling paint for marine applications. This is one interesting phenomena where by mimicking the shark skin, particularly they have these dermal denticles, you read more about it. When it is in motion, these denticles actually create a low pressure zone. By this low pressure zone, the advancement is possible having the vortex. So this was studied and during the 2008 Olympics. They have used this shark skin material as 98% of the swimmers wearing this swimwear who went unit. By finally, this technology is banned for such application. This is a level the science and technology has learned from these the natural sources. Then another one is on wind turbine. We all know about wind turbine, particularly the one offshore wind turbines. They all have been evolved. There is an inspiration coming from the whale, particularly the blue whale, where it's on the leading edge back whale, particularly which gives a flipper on the hydrodynamic advantage. We all talk about hydrodynamic advantage. When I visited Canada, where the major model studies have been done for the tidal energy, I was told that the conventional fixed blades are no more useful. We have to learn from this nature, go for a flipping type of wings to have this type of tidal energy. Here comes again angle of attack. How the angle of attack on the flipper stall, we all know about stall. When we aircraft flies, the difference in pressure, sometimes it can disrupt it. How these animals are overcoming this stall-induced clashes, particularly the fighter planes can use it because they in a very high supersonic speed. Even the naval submarine could make more nimble out of that. And these tubercles can effectively channel the airflow. This is what the right column picture, bottom picture, it has been depicted, and they are trying to mimic this wind turbine blade using this type of technique over there. Here is a picture. You can see sort of octopus is camouflaged. How the octopus is able to understand the pattern of the soil where they are there on the seabed to camouflage themselves to attack the predator. This is very interesting picture, which there are also studies. One of my good friend, Hanuman Singh from Utsal Oceanographic Institute, he is working on morphing of these images. There's a big discipline where the students can start thinking about it using AI and ML technique. So he has been recently he had given a talk to our institute and he has shown such pictures, how they are able to understand about this when they go for an underwater mapping. Now, cephalopod is similar, like we have seen it earlier in squids. They also have got the same capability. They've got a bioluminescence. This is trying to copied by the soldiers when they can wear the similar type of dresses for the bioluminescence and activity, so that can make them to get camouflage during their warfare activity. This is a very interesting thing. One of this research which is happening is to understand about octopus. They have got little bit advanced brain. We know very well, even for the football match, there was a time in Germany they were trying to look at one of the lobster, Victor, over there. So research is a lot of things are happening on biotechnology, particularly on the mechanical engineering discipline over there. Now, we all know about fish, they swim. How do they swim behind? This is an interesting part of it. You all should know about it, how they created waves and turbulence. And by having these waves, you can see the bottom picture where the forward movement of vortex is possible. And the same fishes can create a reverse flow by having this reverse vortex. This is a very interesting thing. If at all we successfully duplicate it, that will be very good for propulsion applications. Here, there is a current understanding on the locomotion part of it. The researchers were able to document. I'm sure I learned that Shubham Sim is also working on Atlantic salmon fish. He approached me to get the exact dimensions. Unfortunately, even the top researchers don't have. Normally, we try to have our own extrapolation of the existing data to simulate his work. So he's working on 3D model. Similar such work is possible to understand about that. So this is a documentation of the locomotion knowledge, what we have gathered from these animals. Now, there exists a problem, particularly on the solution where how do you have the streamlined body, how this can be useful for autonomous underwater vehicle design. There are also regiform EVs which have been developed now. Various tests are being done. Germany, they are doing leading work on this, and they are trying to mimic. The basic reason here is the UVs, they got a limitation. Even we are buying an autonomous underwater vehicle to work at 5,000 meter in the Indian Ocean. It's costing more than 70 crore. But the limitation there is the energy or the battery capacity what you got. So as long as you are able to save energy for your activity, it will be very good for us to collect more amount of data. That is what we are trying to see, how in nature these fishes are able to conserve energy and move and have they move forward in their activity. We started a very small activity on Aquaboat, trying to mimic and robofish we tried to make. And one of my colleagues, Mr. Jagdish, now he is doing his doctoral studies in IIT Indore. He has been working on it. And basically what we thought was there is, among all the things, simplest thing is to have this ostraciform propulsion where only the fin and the back fin is, rear fin is used. And also, even though body shape is not so good, it may not give the good locomotion example, but this is possible for us to mimic and trying to do it in the laboratory condition. That's what we have chosen as the simplest part. We are also working with Virginia Tech Virginia Tech University in USA. We have signed an agreement to understand about that. There are also systematic laboratory studies we have done, tested it in the lab, and we have also tried in the open ocean. But the challenge for us is ocean current is so strong, the propulsion what we had a limitation on the movement of this. It worked in the closed environment, but still we need to go a long way to that. There's also a Bionic Octopus, which is preliminary design stage. But what we have got with us is how do you have this torque produced by this? Because the conventional, we have also looked into the conventional motor and the gearbox and what is available with the stepper motor, and it's not possible to have the high energy torque which is required to have a duplication. Here comes more understanding because these are all the conventional models. Now we have to think of a really high end, which should be miniaturized and should have a high end model. Next is on BII, Biologically Inspired Innovations. We have also started collaborating with them on a jellyfish. We know very well the jellyfish, they move as a group and they don't have brain, but still the important point is that animal propulsion is 1 to 2 order of magnitude more efficient than the human design vehicle. Among the animals, jellyfish swimmers, they have got the lowest known cost of transport. When you talk about cost of transport, it is very less, particularly on vortex formation. This is an interesting data. You can also refer further. Here they clearly given the weight versus the cost of transportation, where the jellyfish plays a major role. Herein, And from the nature, they've evolved these measured these winds, and they have done the clay model studies. The model studies have clearly shown that when they have such a duplication of this, it is possible to have a higher speed. Next, I will switch over slightly onto the biofouling. That is nothing but growth of marine organisms, which we start when we are morning, when we see a cup, when you for toothbrush, we have a slime formation. It can exist anywhere. This slime get into polysaccharides and finally a single bacterium and subsequently bacterial cell and leading to macrofouling. This type of growth is very common in our waters, in tropical waters where we have a sunlight, and this growth can extend even up to 25-30 meter down below. And how do you protect this instrument? How do you protect the ship hulls? This is a big challenge. We are all working on it. Some of them are detrimental. They can produce acids to deteriorate the material. Here comes the nature where the Lotus effect was taken note of it. The coefficient of friction is very important. We have done some studies and we have duplicated and we have collaborated with Indo-Bulgarian program wherein silicon-based systems were evolved and we have tested off Chennai and we have a patent for it. And the similar effect is really useful. Unfortunately, since it's not a full screen, the Lotus Leaf video is not visible for you. Now, one side we are talking about adhesive, or we don't want it. Other side, we should try to see how in nature these animals are able to adhere to the wet surface underwater. When human is not able to have a wet paint which can be applied, even the ship to be dry docked, taken out of water and repainted and used. However, in nature, these animals are able to get adhered to that. It is reported that more than 1,700 species are there in our water. We have done one studies with IIT Madras. We are trying to duplicate, and we understood with three different substrate of acrylic, titanium, and stainless steel. One student have done a very good work, and this cement structure clearly shows that the animals had the ability to understand about the surface roughness could be, and there is a variation in the thickness, particularly similar to the bark of a tree. They have a concentric circle on which this excretion of this adhesion takes place. The adhesion is so strong that once it is exposed to ultraviolet radiation, it's very difficult to remove. As long as it is soft, it is possible to remove. Still, we should learn a lot on this and trying to simulate or the synthesize in the laboratory condition. Another challenge when you talk about animals, the microbes are so strong, they are present everywhere underwater. It is reported that the Titanic shipwreck, which is lying more than 100 years down below in seabed, can get eaten away by these microbes. Similar such experience we faced by having tsunami early warning system sensor deployed in deep ocean at 3,300 meter in Bengal. After 18 months, we found a severe corrosion that is again lead to microbes, which is affecting the material what we are using. So this is what we should know. Today we are talking about COVID, where the microbes can play havoc and disturb our lifestyle. Similar like that, it can happen in underwater. Any of these systems what we design for underwater application, particularly for long term, we need to look at these aspects in a critical manner. Finally, last but one slide. I am trying to make it very fast because of paucity of time. But these topics, what I touched upon, definitely would make you to show an interest because I teach in IIT Madras on ocean policy, and IIT Kharagpur and IIT Bhubaneswar. All these type of topics when I give, I always feel that students come back to me with more and more interest. Here is a glass sponge. Animal sponge is an animal can produce a glass at a 200-meter depth. We have collected off Andaman. It's a very interesting phenomena that there are optical properties which is similar to optical fiber. We could correlate with that. With this, biomimicry is a method of creating solution to human challenges by emulating designs and ideas found in the nature. Sometimes the best solution is to a problem isn't always the most complex, and similarly, the best answer is always a new one. While the humans may just be getting our feet wet, particularly in the with ingenuity, but the animal kingdom has evolved over millions of years. So we need to learn a lot with a limited knowledge, limited understanding what you have got. But however, I'm sure that with recent tools like AI and ML and the advanced knowledge you have got, I'm seeing a lot of work being done by having the simulation over in the laboratory condition. The students who are listening will take forward, will look for a newer finding. I'm sure that they will contribute to the society. Thank you once again. Thank you to the principal and the dean for sharing with us on this important discussion. Thank you very much.
Thank you so much, sir, for that lovely and very informative topic. I'm pretty sure a few of us will be contacting you on if with their interests. Next, we have Nanda sir. Mr. Nanda Kumar started his career in offshore drilling in 1981 as a communication and air traffic controller. He then worked in merchant ships as a radio officer and diversified from the communication side to the navigating side and rose up to the rank of chief officer. After a 10-year stint in the offshore and merchant marine industry, Mr. Kumar became a Department of Trade and Industries examiner for GMDSS and was the pioneer in starting and implementing the GMDSS regulation in India. Mr. Kumar is often consulted on maritime communication and security issues by many governments. Besides various landmark achievements such as setting up the VVIP communication network for India, his company has the credit for providing satellite communication services for presidential aircrafts of three countries. In addition, his company provides ISR and marine domain awareness solutions for many countries on the water, above water, and underwater. He is a passionate and dedicated promoter of safety at sea and oversea for the past 25 years. I would like to welcome Mr. Nandakumar, sir. Thank you for joining us today, sir. I'll be handing over the podium to you.
1 minute, Ms. Salma, can you take a group picture? Shubham, have you taken anything? We have a principal with us for our records. Maybe we can tell them to switch on the video.
Sure, sir. Shubham, I think I'll ask you to stop presenting for a while so that we can have the group photo. I request everyone to please turn on their mics. Sorry, cameras.
Camera. Try to capture as much as possible. Yes.
Yes. Someone, could you please take the group photograph? I think you're controlling it from the admin side. Someone, am I audible?
Yeah, you're audible. Someone has to take picture.
I think she has taken. I'll also take from my side also.
Hema, you can also take from our side.
Knowing Hema, she must have already done it.
Yes, sir. I've done it.
She should have done it already. Thank you, Mr. Nanda. Thank
you.
Thank you, Hema. So we can. Thank you, Salma, for the introduction. And while Shabnam is starting the presentation, very good morning and good day to the guest of honors, the Professor Parvez and Professor Sufyan. Good morning, sir, again. Greetings from MTS India. And a big thanks to Professor Salim Anwar as well, who is the staff counselor and for the MTS section. And all the other students in the organizing committee as well as who have logged in. A very warm greeting from MTS India section. My name is Nanda Kumar and I'm here to talk to you on a subject above water. While Dr. Venkateshan was dealing with all the marine living organisms under the water, technology has come a long way. As you can see, we have come a long way from the horse carriage to a motor car, and now even flying men are going to be possible in the next couple of years. And I come from an era where I started my career in Morse telegraphy and ended it in high-speed satellite communications. So this has given an immense change in the way we work at sea and live at sea. Next slide, please. Unfortunately, my slide. So the million-dollar question I always ask everybody at sea is, don't you think that in this age and technology, that ships anywhere in the world should have hospital-like diagnostics? So that point you see there is called Point Nemo, and that's the farthest point, what we call as the godforsaken mid-sea. And with today's technology, we believe that even out there, you should have hospital-like diagnostic. Next slide, please. So today's topic is about shore-like care at sea. We have a lot of people working out at sea. We have scientists like Dr. Venkateshan and his team working in the middle of the ocean. They work in the Antarctic. They work in very inhumane weather and conditions. And there is now a move that people out at sea should also have similar care and diagnostic solutions like what you have on land. So there is what is called as the Maritime Labor Convention, MLC, who have now specified certain requirements for the sea, for the seafarers. Next slide, please. So what is the scale of the problem? We have around 60,000 ships, over 1.5 million seafarers and scientists working on these ships. There are only 15 telemedical maritime assistance services. There are 15 radio services where people can call from a ship on a radio for medical advice. And annually, around 20,000 people are assisted for emergency. And there are 2,000 medical evacuation. That means somebody is taken out from the middle of the sea using a helicopter or a ship. And the problem is that most ships don't have any medical devices or any medical kit. And the ships do not have any medical wellness programs. And the current way everybody is reporting is only verbally. Just call somebody and say, I have a headache, I can't breathe, but can you advise me? Next slide, please. So what are the regulations to comply? One of the reasons I am doing this presentation in this section is that I want the students and faculty members to concentrate on this very, very neglected area where, as I speak today, believe me, none of these facilities exist on a ship. What I'm presenting to you is a concept that can easily be adapted. Yes, there are working models on that, but I'm sure that bright students can improvise on this and make it more cost effective. These are the regulations. We have a regulation in place. One is the International Maritime Health Association. The other regulatory body is the Standard of Training and Certification and Watchkeeping. And then we have the Maritime Labor Convention. Each of these three organizations are the ones who regulate what happens on board a ship. Next, please. So what are the key points of the Maritime Labor Convention? It says that everybody at sea should have a prearranged medical advice available 24/7. The MLC requires that seafarers should require medical care similar to the one they have on the shore, like what we have in the cities. And they are putting the onus of the medical care on the owners of the ship. It's the ship owner's responsibility to have this. And they have formulated various revisions of the MLC convention to meet this requirement. Next slide, please. So we all know out at sea, accidents and sickness can simply happen. There's no way you can prevent it. These things happen. And I have been associated with NIOT for more than 15 years on a lot of their cruises. We have had our share of our emergencies as well. So the most important is you cannot prevent an accident or sickness, but are we prepared if that happens? Next slide, please. So this is the statistics put out by the International Maritime Organization and the International Maritime Health. that 1 in 5 ships are always diverted for a medical reason. If there was some kind of a telemedicine, they can prevent diversion by about 20%. This 20% can result in a saving of $168 million per year for the shipping industry. And the average cost per diversion is about $180,000. Next slide, please. So why are vital signs important? We all know that the entire body, we need 5 vital parameters to make sure the next course of treatment. Whatever happens, you may have a stomach ache, you can have COVID, you can have any disease. These 5 vital signs are very important to decide on the way the doctor would treat you. And it also determines the treatment protocols, and it also defines and determines critical information that is required for making, for subscribing the required medicines. And it also needs to be documented. All the vital signs need to be documented. Next slide, please. So we are getting into a new age. It's time that all the crew, means now I'm talking only from the maritime point of view, from the marine world point of view, that it's time we had something called as the digital health passport, which means we focus on integration, interoperability, and accessibility of medical records from the time a person joins to the time of retirement. We call it the lifetime health record, which is one crew, one record. Next slide, please. So here I want to highlight a little bit of a misconception between the word telemedicine and telehealth. Today, everybody is talking about telemedicine. Telemedicine is actually a clinical application of the technology. In short, it is just like somebody picking up the phone. If you called your mother or your doctor and say, I have a headache, that is telemedicine. And that is, unfortunately, I had a call from the managing director of BSNL the other day, and he says, Mr. Nanda, I want to discuss telehealth with you, because everybody here in telemedicine, they are, calling teleconference as telemedicine. So here is where we have to be very clear: telemedicine versus telehealth. Telehealth is telemedicine plus health surveillance, health promotion, and a lot of other public health functions. It is a wide range of technology and service, and everything is evidence-based. It is just not calling somebody and telling, I have a stomach ache. It's like sending the proof of your readings and then discussing with the doctor on a telecall. So telemedicine is application of clinical technology, whereas telehealth is telemedicine plus a lot of other things. Next slide, please. So connecting a ship to a telemedical assistance center or a hospital is very, very important. And in today's world, ships are getting smart. So why can't we have smart health? So we are looking at Uberization of maritime healthcare. Next slide, please. So all this is happening only because connectivity at sea is making the difference. Today, with new ships, today we call our ships digital ships. New technology, we have satellite communications that are currently being installed that will do better speeds than what you have at home. So I started from, as I told you, from a Morse code telegraphy era. And when I left sea and started my business, the fastest speed you could get was 2.4 kbps. Most of you won't even know what it is. But today we are looking at a speed of 50 megabits per second. Once you have 50 megabits per second on the ship, everything changes. You can have anything that you have in your office or home on board the ship. So this is helping accelerate the new technology. We have connected ships, we have telemetry, we have telemedicine and telemaintenance. Next slide, please. So this is where this kit comes into a picture. We call it the emergency golden hour kit. And one of the biggest problems that we face in the maritime world is mental health. So that is a topic that most people skirt around. They don't talk about mental health, but that is what is seriously affecting the maritime industry, because the seafarers, the people working at the sea, who miss their family, who miss their loved ones away from land, they get into some kind of mental health issues, and this can also be addressed by the entire solution. Next slide, please. So this normally a telehealth kit would contain a tablet, and it would contain several devices like multi-blood parameters, a ECG, pulse oximetry, a blood pressure, and a lot of other rapid tests. We can include what is called as the troponin I and troponin T. These are tests that will immediately tell you if you have had a silent heart attack or not. Then you have rapid tests for malaria, dengue, COVID-19. So these are all things that can be put into the kit. Next slide, please. So as I was telling you, these are the tests that can be done in a more detailed manner. And all these test results are captured in the tablet PC. Next slide, please. And once it is captured on the tablet PC, it can be sent via any mode of communication to a secure web server on land. So you can be in the middle of the sea using a satellite communication link. You can send it to the land. And by doing this, we also adhere to the United Nations SDGs, Sustainable Development Goal number 3 of good health and well-being. Next slide, please. So this is how the concept works. All the devices connect to the tab using any modes of communication. Could be just a plain Wi-Fi, 3G, 4G, LTE, or satellite. It could be on an aircraft. It could be on a ship. It could be in the middle of the jungle. All the data of Seychelles in peak summer, and somebody is working on the deck. Suddenly he faints. Or let me put it this way, that you're on an aircraft and somebody faints in the aircraft. There's a cabin crew who will come running and ask you, is there a doctor on board? And if there's a doctor on board, he can come and see the passenger. What can he do with it? Suddenly he can just feel his pulse, and maybe there's a stethoscope. And if the passenger is not responding, somebody faints in the aircraft, they would have to divert the aircraft. Come running and ask you, is there a doctor on board? The same thing happens on the ship. If there's a doctor, if you don't have any tools with you, you need to kind of divert the ship. So if there is no telemedicine or telehealth solution on board the ship, next slide, please. But on the other hand, if you had a telehealth solution on the ship, what would you do? If somebody falls down fainting, you immediately connect all the devices and you measure his blood pressure, you measure his ECG, you measure his pulse oxygen and temperature. And then you will see that if the doctor on board or even an ordinary person sees that everything is all right, then he could have pain, and then he finds that his sugar level was low. There's nothing to worry about. They'll probably give him a Coca-Cola or a Pepsi or some lime juice with sugar, and he will be sitting up and normal in the next 5 or 10 minutes. So this is a very, very important decision that has to be made, because a diversion on a ship costs 180,000. That's how much ships have spent. And aircrafts spend about much lesser, because there's an airport every 100 miles or so. So this is how I would explain or stress on the importance of telemedicine or telehealth solution in any remote location. Next, please. So what are the benefits for the ship owner? For the ship owner, it reduces the anxiety and stress of the captain. Imagine you're the captain of a ship and you have a crew who is not well and you don't know what to do. Here you connect him with one of these telehealth kits, and then the doctor, Apollo Hospitals or somebody else, one of the big hospital doctor can say, hey, nothing to worry about. He is okay, just give him this medicine and he can be hospitalized in the next port. Also, This meets with the MLC requirement of a 24/7 connectivity at sea. Not only that, imagine the prestige of your company. Everybody would say, oh, my company cares for me, my owners care for me, my boss cares for me, so that the crew or the people working have a better opinion and high opinion of the owners. And above all, it saves money for the ship owners. It saves money for everybody. And in today's term, we should also talk about saving the environment, because if the ship is diverted, you're spending more money on fuel, you're burning more, creating more greenhouse effects, burning more fuel. So overall, it is a big benefit for the ship owner. Next slide, please. So at the end of the day, it's a win-win for all. If you have some kind of a telehealth solution on board a ship, for the ship, it is a general wellness monitoring, it is evidence-based, and a ship can call a telemedical assistance service or Apollo hospitals or any hospital giving exact detail of the problem. For the ship owners, it gives them a very good impression in the market that they are owners who care for the crew. It also reduces insurance payment. It also creates a wellness program. And most important of all, for the doctors, it's a very big boom, because today most of the doctors who are answering such calls don't exactly know what is happening on board the ship, because on the other end, whoever is describing is not a medical professional. So they are always in a state of panic. They are screaming and shouting. So when you have an evidence-based vital signs reported, the specialist doctor on this ship can actually take an informed decision and then eradicates all these conflicting variations. Because normally when you talk to doctors, they say from the first call reporting the problem to the last call, the diagnostics have changed. Next slide, please. So that's where it is. That's the end of my presentation. And that's a joke I have, that according to research, salary increases can lower the risk of heart disease. So this is something you can talk to your bosses for pay increment. Thank you, guys.
Thank you so much, sir. That was very enlightening. Now we have come towards the end of our program. I would like to request our faculty advisor, Salim Anwar sir, to please address the audience.
Good afternoon and Assalamu alaikum. I will begin by thanking Dr. R Venkateshan, the Chair, MTS Society India Section, and Mr. Chandrakumar sir, Secretary of MTS India Section, for gracing the occasion with their. Take care, bye-bye.